Okay, students, sorry I reply a message to some of your friends as first because they are not able to join us today. Okay, so without further ado, good morning, students of 4 Akid and 4 Baiduri. So how are you this morning? Are you doing good? Can you give me some response? Are you doing good there? Okay. Okay, have still have some friends who are just admitted sleepy. Okay, Jiwei. If you feel sleepy, you can put your drinking water aside you or just go and have some refreshment. Okay, you boleh makan sambil ada kelas ini no problem, tak ada masalah. Alright, so I think we can begin now. So without further ado, I will start my presentation. So this is student 6.1, Refraction of Light, the first learning standard on chapter 6, Light and Optics. Alright? Okay, so actually we have learned refraction in chapter 5. Do you remember refraction of wave? Remember? Refraction of wave in 5.5. Okay, refraction of wave. So anybody remember what refraction refers to? Anyone? Refraction. What is refraction? Refraction, we learn in chapter 5, refraction of wave is the changing in direction. Okay, when wave travel through the medium of water with different depth. Somebody is still asking to join, so I admit them first. Sorry for the interruption. That's why I prefer you join earlier so it won't be disturb our lesson while we are discussing. Okay, but never mind. So I hope tomorrow you will join earlier so there will be no disturbance, okay, during the discussion. Okay, students, so I continue. Okay, so our first learning standard is 6.1.1 to describe refraction of light. All right. Okay, so before we go to the definition for refraction of light, so let us take a look at these three example of simple daily phenomenon first. Later you can try on your own. Okay, all these things except for the thermometer can be found in your kitchen, right? Okay, so in the first diagram you can see a thermometer appears to be bent, okay, in oil and water. Okay, you can see it bend when the thermometer is moving through the oil on the top layer and water at the bottom. Okay, and in the second GIF, you can see what happened. Initially, we put a coin into an empty bowl and it is not visible. Okay, but the moment we fill up the bowl with a cup of water, you will start to see the coin is now visible, able to be seen. Okay, and then the third example, if you draw an arrow on a wall and then you place an empty glass in front of it, and later when you fill the glass with water, you will see the direction of the arrow will be changes. So actually this is not a magic show, but all to do with physics concept called as refraction of light. Okay. Okay, I admit some friends first. Sorry for the interruption. Okay, already in. Okay, students. Okay, let us continue. So this is the three example of daily phenomenon can be related to refraction of light. Okay, now next. Before we go further, let us take a look first at the characteristic of light. Okay, characteristic of light. So if you look at the GIF, we have a light travel from A, entering a glass, and then went back to A, right? So first we understand light can pass through any transparent object, okay, such as air and glass. Can you give me a few more example of transparent object other than air and glass? Anyone? Anyone? Okay, you can type your answer in the in-call messages as well. Plastic, yes, very good. What else? Transparent object. Okay, air, glass, plastic, and then we have diamond, perspex, and so on. Okay, very good. And then when they travel in this transparent medium or transparent object, so what happened? They travel in a straight line. Okay, you can see in the air, it travel in a straight line. Entering glass, you can see the direction changes, it bend, but still in a straight line motion. Okay, so light travel in a straight line when pass through one transparent medium to another. Okay, then student, how does light travel in a medium? Okay, so again, you can see this GIF from air entering glass and then went back to air. And the second diagram down here, initially the light is travel in the first medium, which is air, and then entering the second medium, which is the glass block. So what can we find here? Number one, light rays bend. Bend here refers to changing in direction. Okay, when traveling from the air, the first medium, into the glass block, the second medium. Second, we understand when light travel from air into glass block, the speed or velocity is reduced due to the uh, glass particle. Okay, when light travel from air into the glass block, its speed is reduced by the glass particle. So here we understand light travel faster in A. Okay, it travels slower in glass. Okay, then number three, the changes in speed will causes the ray of the light to be change direction. Okay, so changing in speed will causes changing in direction. So by this we say the light ray is refracted. Okay, the light ray is refracted. Okay, then next, this is another important things I want you to understand. Okay, density versus optical density. So student, when we talk about refraction of light, the two mediums where the light travel at, okay, actually we consider it optical density. Okay, they are different in optical density, not in density. Okay, what is the difference between density and optical density? Okay, density defined as mass per unit volume. Okay, rho equal to m divide v, the formula for density. Okay, but what is optical density? Optical density is a measurement, okay, which shows ability of an optical material, which is the transparent material, to absorb or to bend light which travels through it. Okay, I repeat, optical density is the ability of the transparent material to absorb or to bend light which travels through it. So can you see the difference between density and optical density? I give you a very simple example. If we compare oil and water, everybody knows oil has a lower density compared to water. That's why it floats on the water surface in this cup because it has less dense compared to water. But when talking about optical density of oil and water, oil has a higher optical density compared to water. Okay, if you look at this diagram, when we put a thermometer into this beaker containing of layers of oil and water, you can see that the thermometer bend more in the oil. Okay, it bend less in the water. The red dotted line is the actual path, okay, of the thermometer in A. So you can see in oil, okay, the thermometer bends more from the original part. Okay, this is because it has higher optical density, which means oil able to refract light more than water. Oil able to bend light more than water. Okay, so here down in water, the thermometer bend less from the original part. So we understand water has a lower optical density compared to oil. Okay, so later you can come back to this slide and read again to understand more what is the difference between density and optical density. But I want you to remind, whenever we discuss about refraction of light, it is always referred to the optical density of the material instead of density. Alright, so density is not equal to optical density. Okay, next, okay, students. Okay, a medium that can reduce, when we talk about optical density of a medium that can reduce the speed of light said to have a higher optical density as we compare oil and water just now. Okay, second, you have to understand that the higher the optical density of a material, so what happened, the lower the light speed that propagating through it. Okay, which means the light will be bent more from the original part. So it will refract more, right? So here, we can write the conclusion. When light travel through medium of different optical densities, so the change in light speed will causes refraction of light, which is the changes in direction. So can you follow me so far until this point? So we are getting closer to the definition of refraction of light. Okay, so we can write the definition now. Okay, so actually you can find this from your textbook. Okay, here you can see one simple demonstration when you directed a laser pointer to a glass block. So you can see the light will be show refraction effect. So this one, initially we put it at the normal line, so no refraction occur at normal, but when you change the angle of incidence, okay, refraction started to occur. Okay, so what is the definition of refraction of light, student? It is the change in direction of light, okay, which occur due to the change in speed of light when traveling through two mediums of different optical density. Okay, I think you can add on, okay, or you can write the definition for refraction of light in your module. Okay, refraction of light is the change in direction of light which occur due to the change in speed of light when traveling through two medium of different optical density. So the highlighted word is the three keywords for definition of refraction of light. Okay. So do you have any questions so far? Anything you would like to ask? Are you clear up to this point? Boleh faham cikgu ke? You can respond, type your respond in the info messages. Yes, if you can follow me. Okay. Or if you have any question, you can turn on your mic and just ask for anything related to our discussion now. Okay, if no questions, so I think we continue. So this is the definition again. Okay, then students. Okay, let us take a look at the next example. Okay, now in figure A, we have refraction of light from A, our first medium, to glass block, our second medium. Okay, so this is the blue ray showing that the light is travel from the air and then entering a glass. So you can see it refract towards or away from normal. Towards or away, both the blue light and the red light down here. From A to glass, you can see it is refracted towards the normal. Okay, refract towards the normal where angle of refraction is smaller. So based on figure A, what can we say about the phenomenon occurs here? Number one, the light ray bend towards the normal, okay, or refract towards the normal when travel from a medium of low optical density, which is air, to a medium of high optical density, which is the glass block. Okay, Second, you can see why. So because the speed of light decreases or reduce as it travels from optically less dense medium to a optically denser medium. Okay, and then from here we can say the angle of refraction is smaller than angle of incidence. So R less than I. So this is what happened when light ray travel from less optical dense medium to a greater optical denser medium. All right. Okay. Then second, figure B. Okay, figure B is the opposite to figure A. Okay, now refraction occur from glass block an optically high dense medium to air, less optically dense medium. So based on figure B, again you can see the blue light. Okay, the light it travels from glass entering air, the second medium. Now, so now you can see it refracted away from the normal. Down here also the same. The light ray is coming from the glass, went upward and comes out to the air. So again, you can see it refract away from the normal. So in this figure, what do we understand? Light ray bend away from the normal when travel from a medium of high optical density, which is the glass block, to a medium of low optical density, which is the air. Alright? Okay, then second, why? This is because the speed of light increases as it travels from optically denser to a less dense medium. Okay, so what happened? Angle of refraction will be greater than angle of incidence. R greater than I. Okay, so figure A and figure B. Okay, so students, this table contain 5 or 6 important terms for you to understand very well if you want to do good in refraction of light. Okay, the first one is normal. Okay, what is normal? Normal line is the dashed line. Normally, we draw a dashed line. It is a line perpendicular on 90 degree to the boundary of the two medium. Okay, this is the normal. Okay, then we have incident ray. What is incident ray? The light ray in the first medium, traveling in the first medium. Okay, and angle of incidence, I. Okay, what is angle of incidence? It is an angle between the incident ray and the normal. And then refracted ray. What is refracted ray? The ray in the second medium. Okay, angle of refraction is the angle between refracted ray and the normal line. And last but not least, we have angle of deviation with the symbol of sigma, right? So what is angle of deviation? You can see angle of deviation there. It is an angle between the refracted ray and the original path of the first medium. So if I zoom out for you, you can see I there, and this is R, and this is sigma, the angle of deviation. Okay, the difference between the angle between the actual path in the air and then the refracted ray in the second medium. Okay. Okay, next student. So done with the first learning standard to understand refraction of light. Okay, so now let us go to the second learning standard to explain refractive index. And so what is refractive index? Okay, refractive index and the relationship with the bending ability of a medium. Okay, so in this diagram, you can see on top, we have light ray traveling from the air and then entering water. Okay, down here, we have the same light ray traveling in the air, but now entering diamond. Okay, it is stated there, water has refractive index of 1.33. Okay, and diamond has a higher refractive index of 2.42. Okay, so this is the refracted ray in the water, and this is the refracted ray in diamond. Theta 1 is the angle of deviation, okay, in water, and theta 2 is the angle of deviation in diamond. Okay, so where is the angle of incidence and angle of refraction? Our angle of incidence is here. So this is our angle of incidence, I. This is also our angle of incidence. Okay, angle of incidence is equal. Okay, where is our angle of refraction? Angle of refraction is here. This is angle of refraction in water, and this is angle of refraction in diamond. Okay, you can see that angle of refraction in diamond is smaller. Okay, so we understand why smaller. So we understand the light refracted more towards normal when entering diamond, right? So students, what is actually refractive index? Okay, so refractive index determines, okay, the degree defined as the degree to which a light bend when traveling from vacuum or air to a medium. Okay, I repeat, refractive index determine the degree to which light bend when traveling from vacuum or air to a medium. Okay, so it indicates the bending ability of the medium. So can you tell me, if we compare water and diamond, which medium has a higher bending ability, diamond or water? Which medium has a higher bending ability? Mean they able to bend more light that travel through them, diamond or water? Answer is, answer supposed to be diamond. Yes, answer supposed to be diamond. Yes, very good. Thank you for your response. Okay, so okay, then what we have next? Okay, theta 1, theta 2, as I mentioned, this is the angle of deviation in both medium. Okay, where here you can see clearly theta 2 is greater than theta 1. Okay, so next what we can say here, the higher the refractive index, so the greater the bending ability or the bending effect, because uh, the medium able to slow down light more. Mean the particle is more closer in diamond compared to water. So it able to reduce more speed of light. Okay. Okay, then so as the result, it will cause us a larger angle of deviation of the ray, which means the light will bend more towards the normal. So this will produce smaller value of R, angle of refraction. All right. Okay, next. Okay, so how can we write refractive index if asked in the question? Okay, so let's say the question asks, define refractive index. What is the meaning of refractive index? So what is the definition for refractive index? So we write it this way. Refractive index is the ratio. Okay, it's a ratio of speed of light in vacuum to the speed of light in medium. Vacuum here also including air. Okay, so refractive index is the ratio, a ratio of speed of light in vacuum to the speed of light in medium. When you give the definition, please don't give this formula. Okay, write them in word, ratio of speed of light in vacuum to the speed of light in medium. So speed of light in vacuum, the symbol is C, and the value is 3 times 10 power of 8 meter per second. Okay, and speed of light in medium is V. So it depends on what medium. Okay, each medium has different speed or velocity. Okay, and this table shows to you the refractive index of a common medium we normally use in physics. For vacuum and air, the refractive index is 1. Okay, somebody is trying to admit. I admit him first. Okay, welcome. Okay, then students. Okay, for water, it is 1.33, the refractive index. For olive oil, 1.46. For specs, 1.5. For glass, a crown type, 1.52. For glass, a flint type, 1.66, and 2.42 for diamond. Okay, so these three figure actually I cut and paste from your textbook. So you can see the first medium, we all have water. Okay, water, here also water, here also water. The difference is in the second medium. Okay, so first diagram on the left, light travel from water to perspex. Second diagram, light travel from water to glass, flint type. And then third, light travel from water to diamond. And you can see all the angle of incidence is the same with 50 degree. But what is the difference? The difference will be on the angle of refraction, okay, due to the different medium in the second medium. So perspex will give refractive in angle of refraction of 42.8 degree. 37.9 for glass, and 24 from 9 degree for diamond. So if you compare perspex, glass, and diamond from this table, you can understand diamond has a greater refractive index, then followed by glass, and then followed by perspex. So you can see when the refractive index increases, what happens? The angle of refraction decreases, which means diamond refract more light. Okay, the bending ability of diamond is higher due to the higher refractive index. That's why the angle of refraction is smaller. Okay, okay, then. Okay, so let us try this question to see either you understand what I'm explaining to you just now or not. Okay, diagram 2 shows a ray of light travel from medium X to medium Y and then to medium Z. So we have three medium there. So this is the first light in medium X, this is in medium Y, and then in medium Z. So which comparison about the refractive index of the medium is correct? So from medium X to medium Y, you can see is the light refract towards or away from normal, student, from the diagram. From X to Y, refract towards or away from normal? Towards or away? You can see it refract towards normal. Okay. And then later from Y to Z, what happened? The light refract away from normal. Okay, let's say we put an angle here. Let's say I here is 30 degree. Okay, we put angle there 30 degree. 30 darjah, you boleh tanda. And here, let's say the angle here also 30 degree. Okay, and we put here 30 degree. Okay, so angle up here 30 degree, down here angle of refraction also 30 degree. So can you choose which one do you think is the correct answer? Is it A, X equal to Z, then less than Y, or B, X equal to Z, then greater than Y, or C, X less than Y, less than Z, or is it D, X greater than Y, greater than Z? Which one? Okay, which one is your choice? Compare, or which comparison about the refractive index of the medium is correct? Okay, we have X, medium Y, and medium Z. Okay, would you like to try? Okay, so which one is the answer? A, B, C, or D for question 1? So question 1, so medium X and medium Y, since the light ray refract towards normal, so we understand medium Y has a greater refractive index. Okay, medium Y has a greater refractive index. And then from Y to Z, it refract away, so we understand medium Z has a less refractive index compared to medium Y. What about X and Z? Okay, since I here 30 degree, R here also 30 degree, so they have equal refractive index. Okay, they have equal refractive. So the answer should be A. X has the same refractive index with Z, and both has a less refractive index compared to Y. Okay, are you clear? Okay, so this is the idea. The higher the refractive index, the higher the deviation angle. So the smaller the refractive angle. Okay, so what happened? The light bend more towards normal in a higher refractive index medium, which is medium Y. Alright, okay. Okay, that is to do with the second learning standard to understand refractive index. So what is refractive index? Ratio. Okay, ratio of speed of light in vacuum to speed of light in medium. Okay, so next, this is the continuation from refractive index to conceptualize Snell's law. Okay, so Snell's law, S-N-E-L-L apostrophe S, Snell's law. When you write this law, please make sure you spelled it correctly. Okay, so this is the diagram related to this discussion on Snell's law. So first, what can you see here? We have two medium. Medium 1, where the incident ray is at, and then medium 2, where the refracted ray is produced. Okay, and 1 is the refractive index for the first medium. V1 is the speed of light in the first medium. N2 is the refractive index of the second medium, and V2 is the speed of light in the second medium. So theta 1 is the angle of incidence, theta 2 is the angle of refraction. Okay, so Snell's law, before we understand Snell's law, first and foremost, we must understand from this diagram the incident ray, the refracted ray, and the normal all meet at one point. So where is the point? Here at the center. Incident ray directed here. Normal is drawn here. And then refracted ray started from here. So this is the meeting point of all these incident ray, refracted ray, and the normal. And they are in the same plane, in this plane. Okay. Okay, students, according to Snell's law, so this is the physicist introduced Snell's law. He said that N1 sine theta 1 equal to N2 sine theta 2. Okay, N1 sine theta 1 equal to N2 sine theta 2. So when you rearrange this is what it becomes. You put N at the left side. Okay, so N2, and then sine theta you put at one side. So what happened? We bring N1 here, we bring N to this side, and then we bring sine to the left. So N2 divide N1 will be equal to sine theta 1 divide sine theta 2. Okay? I repeat here, N2 divide N1 equal to sine theta 1 divide sine theta 2. Okay. The first medium, if the first medium is air, okay, the first medium is air, so then the refractive index will be 1. Okay, as from the table just now, refractive index for air is 1.00. So which means N1 is 1. Down here is 1. Okay, medium 2, we name it as N. Okay, N2 equal to N. Okay, and then I, angle of incidence, theta 1 in A. So here becomes sine I. Okay. And here sine theta 2. Theta 2 is angle of refraction in the second medium. So sine theta 2 become sine R. So from here, we have this formula. N equal sine I divide sine R. Okay. N equal sine I divide sine R. So this is the formula for Snell's law. Okay, so what is N? N is refractive index. Okay, it is the ratio of sine I to sine R. Okay, if they ask you what is Snell's law is the ratio of sine I to sine R. Okay, and the value is constant. Okay, I repeat, what is Snell's law? Snell's law is the ratio of sine I to sine R. Okay, later we will see example how to use this Snell's law to determine angle of incidence, angle of refraction, or to find refractive index of a medium. Okay, as shown in this example. All right. So we have refraction of light occurs here where the light travels from air entering water with an angle of incidence of 30 degree and angle of refraction of 22 degree. Okay, so this is a very direct question. What is the refractive index of the water? Okay, so refractive index of water is N. Okay, so from Snell's law formula, can you tell me what is the refractive index of water? Is it A, B, C, and or D? Which one? A, B, C, or D. Use the Snell's formula. N equals sine I divide sine R, and let's just press your calculator. You will come with the answer. So anybody would like to share the answer for this question? Okay. So this is the angle given, I 30 degree, angle of incidence in the air, and 22 is angle of refraction in the water. So Snell's law formula, N equals sine I divide sine R. So sine 30 degree divide sine 22. So answer should be C, 1.34. Okay, 1.34. Okay, students. Okay, what about this? Okay, try the second diagram. Okay, now we have light ray traveling from water and then entering the second medium, which is air, right? And given the refractive index of water is 1.33. So in this question, you have to find the angle of refraction. So which angle we are looking for? Find the angle here. Okay, so what is the angle there? Is it 22.1, 41.7, 48.8, or 60.0? Okay, first, you can reject A. Why? Because our light refract away from normal, right? So definitely the angle of refraction somehow must be greater than 30 degree. So you can cancel A, 22.1. So it left you with three other options, B, C, and D. Okay, can you find what is the angle here? Okay, try to find first. You can take your calculator, a rough paper, or you can do the calculation in your module, okay, in the blank spaces provided there. And did you find the answer, students? Any answer there? B, C, O, D? B, C, O, D? Harold, Icheng say B, Jiaran also say B. What about the rest? What do you say? So for this one, answer is B. Okay, why B? Okay, what happened here? Remember, student, whenever you apply Snell's law, okay, please remember, angle of incidence must always be at the optically less dense medium. Okay, so here we apply the principle of reversibility of light. Okay, principle of reversibility of light. So we can reverse the direction of the arrow as if the light is coming from air entering water. So now here become angle of incidence. Okay, and 30 degree become our angle of refraction. So we are looking for I. Okay, so here N is given 1.33 and R is 30 degree. So now we can apply Snell's law. Okay, just do the substitution. N 1.33, sine I, we are looking for sine 30 degree. So just press your calculator. Sine I is 1.33 times sine 30 degree. So then you do add sign, press your calculator for add sign. So I will be 41.7 degree. So yes, thank you. Answer is boy, 41.7 degree. So you can jot down there. Here we apply principle of reversibility of light. Okay, principle of reversibility of light. I type that in the live chat. Principle of reversibility of light. It means that light can travel in both directions, from water to air, from air into water. Right? Okay, next. Okay, now the fourth learning standard. Okay, this is example of experiment which we can apply to determine refractive index for glass block or perspex. Okay, for your information, this is the question for UAS in year 2022, tahun 2022. Soalan ni keluar refraction of light. Okay, this year come out electricity, SPM 2023, ohmic, non-ohmic conductor. The first year also coming from electricity, find EMF of a cell. So if you follow the pattern, the first year is from 5, second year is from 4, third year is from 5. So if according to the pattern, your time 2025, the question might be coming from form 4. Mungkin lah if according to the pattern. But we don't know yet which chapter. Okay, students, so in this experiment, we try to find the relationship between I and R and also to determine refractive index for glass block. So this is all our variable. MV is angle of incidence, RV is angle of refraction, and our constant variable is the refractive index of the glass block. Mean we are using same type of glass block all the time. So the procedure you can read from number 1, we set up the apparatus and then we begin to direct the ray box at the angle of incidence of 15 degrees. So we can use protractor to measure 15 degree. Okay, then you will see the light will be refracted and come up from here. So we measure the angle of refraction also using protractor. Okay, then we repeat by using different angle of incidence of 30 degree, 45, 60 and 70 degree. Okay, and all data are collected and tabulated in a table, and later we plot a graph of I against R and then sine I against sine R. Okay, let's say this is the result collected from this study. Angle of incidence increases from 15 to 80 and then angle of refraction from 10, okay, finally to 41. Okay, so this is sine I. How to find this? Just press your calculator. Sine 15, so we'll get 0.2588. You can try now. Okay, sine 30 degrees, 0.5. Okay, sine R, sine 10, 0.1736. Okay, and then angle of refraction 19, so sine 19 is 0.3256. Okay, and this is the ratio sine I to sine R. So 1.59, 1.44, and down there 1.5. So this is the graph of R against I plotted. Okay, it is a straight line at first, but towards the end it shows a curve pattern. Okay, and then this is the second graph plotted. Graph of sine I, this value against sine R, this value. Okay, for this sine I and sine R graph, it will be a straight line graph from the origin. So here we understand sine I is directly proportional to sine R. Okay, then students, okay, so what analysis or discussion we can make from this study? Number 1, from the table, we understand the angle of refraction in an optically denser medium is smaller than the angle of incidence in the optical less than medium. So angle of refraction in the glass is less compared to angle of incidence in the air. Second, from the table also you can see when angle of incidence increases from 10 to 80, angle of refraction also increases. Okay. Third, we can say the graph of sine I against sine R is a straight line graph through the origin. So we know sine I directly proportional to sine R. Okay. And then when you count the gradient for sine I and sine R graph, the gradient is constant. Okay. Remember how to find the gradient? Find any 2 point along this straight line and then use the formula y2 minus y1 divide x2 minus x1. So you can find the gradient. So the gradient is here as shown in this diagram. I zoom up for you. It is 1.5. Okay, 1.5. So from the result, we understand the average value of ratio is 1.55. This is determined through calculation. Okay. you find the average of the ratio, it gives you 1.55. And from the gradient also, we find the value 1.5. So what is this 1.5? 1.5 is actually the refractive index of the glass block. So remember Snell's law, N equal sine I to sine R. So N is the gradient, which is the refractive index of the glass block. And the value here is 1.5. Okay, so this is one way to determine refractive index of a glass block by using Snell's law formula. Alright, okay, so next. This is another example of phenomenon involving refraction of light, uh, real depth and apparent depth. Okay, have you ever noticed when you jump into a pool, you will find your body appear to be shorter. Okay, if look from above, bila kita terjun kolam, nampak kaki tu lebih pendek from the real leg. So what happened to your body? Actually, that is due to refraction of light. Okay, as mentioned here. Okay, later also you can try, you find a coin, put it in a glass. Okay, and then you try to add on water, and then you will see later the coin appear to be closer to the surface compared to the original depth or a real depth of the coin when no water is put on the glass earlier. So the first diagram, you can see a coin appear closer to the surface of water. Why? This is because light ray from the real coin down here travel through water to the surface. So the first medium is water. Okay, so the light coming from the real coin down here and then it comes out to the air. So what happened? It will refract away from normal. Okay, light ray from the coin moving through water and then entering air. So we understand water has a higher optical density compared to air, or water has a higher refractive index compared to air. So what happened? It will refract away from normal. Okay, then the light refracted away because the speed of light increases. Okay, so what happened? You will see virtual coin, or the image will be seen appear to be closer to the surface, which is above the real point. Okay, so this is another way we can express refractive index of a medium, where N is real depth divide apparent depth. Okay, real depth is capital H, or sometimes use capital D, capital D, donkey. Apparent depth represented by small h, sometimes represented by small d. Okay, so from here we understand there are three ways we can write refractive index. First, N is C per V. Okay, speed of light in A to speed of light in medium. Second, we can write N as sine I divide sine R. Okay, and then third, we can write N to real depth divide apparent depth. So there are three ways to determine refractive index. I repeat first, N equal to C over V. Second, N is sine I over sine R. Okay, and then third, N equal to real depth over apparent depth. Okay, so this is the second diagram involving refracted of light involving real depth and apparent depth. Okay, we put a shielding there on the bed of the pool. So what happened? The light ray coming from the coin, okay, so then it comes out to the air. So you can see it refract away from normal and entering the eyes of the observer. So as we see light travel in a straight line, so this is the dotted line we draw to show the formation of the virtual image, which is shallower than the actual object is. So if they ask you to draw the diagram, they can give you the first diagram you see from top, or here you see from certain angle. So this is the way to draw the first diagram if you see from top, and this is the way to draw the diagram if you see from a side or a certain angle. Alright? Okay, then this is SPM task past year question. Okay, diagram 7.1 shows the ruler appear to be bent in water. Okay, you can see the ruler is bending. Name the light phenomenon involved. Okay, student, what is the light phenomenon involved here? Name the light phenomenon involved. Okay, type your answer in the live chat. What is the phenomenon of light involved here? So answer is refraction of light. When they ask you for phenomenon, highlight light phenomenon. Please highlight. So answer is refraction of light. Okay, number one. And then explain how refraction occur. How the light phenomenon happen. So how? What causes refraction to occur? We discussed from the earlier. So it is due to the speed of light changes when travel through two mediums of different optical densities. Okay, or you can say because the speed of light decreases. Okay, it is due to the speed of light decreases when travel from air to water. So it refracted towards normal. Okay, so okay, you can write the first answer or the second answer to explain how refraction occur that causes the ruler to appear to be bent in water. Alright? So I repeat how we explain because the speed of light changes when travel through two medium of different optical density. So this is the general answer. Or you can be more specified, which is better. So you understand the speed of light decreases when travel from air to water. So it refracts towards normal. Okay, maybe you can write this answer in a space, blank space provided there in your module. I'll give you some time to copy because we still have a long way to go. Now, just 10 past 03 a.m. But if we finish earlier, we don't have to wait until 11. So you can do your other things. Okay. Are you done with the answer? Okay. So can we go to the next slide, students? Okay, thank you. Done. Okay, again, the phenomenon is refraction, refraction of light, and then this is the explanation. The speed of light or the velocity of light decreases when travel from air to water, so it refracted towards normal. All right. Okay. Okay, then what will be coming next? This is the next question B. Okay, diagram 7.2 shows the man shooting a fish as seen by him in water. So this is the shooter and this is the fish down there. Right? But his shooting does not hit the fish. Tak kena. Dia tembak tak kena. Okay. First question. Give one reason why his shooting fails to hit the fish. Why? Kenapa dia tembak tak kena? Why do you think his shooting failed to hit the fish? So, any idea? So what happened? So what happened here? Because he is shooting at the image of the fish. Okay. Actually, the man is shooting at the image of the fish. And that is the reason. He is shooting at the image of the fish. So where is the actual fish at? So this is the question we need to answer in diagram 7.2. Question 7.2 B2. Draw two light rays to determine the actual position of the fish. So draw two light rays to determine the actual position. So you can take your pencil and ruler and draw where is the actual fish is at. Mark with X the actual position of the fish. So you can refer to the diagram earlier, this one, okay, to draw the actual position of the fish. Okay. So how to draw? Student, this is how we draw the diagram. So first, what happened? You draw a straight line from the image to light ray entering the eyes of the observer. Okay, two straight line. And then from the border, we draw a line which is refract closer to the normal. Okay, so this is the light in the air. So we draw the line refracted closer to the normal in the water. The second line also from this line at the boundary, we draw a light ray refracted closer to the normal in water. So this is the intersecting point of these two light ray. This is where the actual fish is at. So you label with X. You don't have to draw the fish, so you just have to label with X. So actually the actual fish is below the image appear at the shooter's eye. Okay. Sebab tu dia tembak tak kena, dia tembak at the image, not shooting at the actual fish. So, the next question, are you done with your drawing? So again, I repeat how to draw. First, you draw a straight line from the image, two straight line, okay, straight line from the water and then straight line to the air. And then for the refracted ray, so from this boundary, we draw a line refracted closer. This line also, we draw a line refracted closer in water. So they meet at this point. This is where the actual fish is at. Alright? Okay. If you draw one line, I'm afraid it will be rejected. Normally, we draw two lines for refract. It is also stated clearly in the question. Draw two light rays. Determine. Okay, so first is the black. Second ray is the red color. Okay, tapi dalam lukisan tak perlulah guna two different color. Use the same ink pen, blue or black. Right? Okay, then next. Okay, see, give one suggestion how to shoot the fish accurately. Okay, we have draw the diagram showing the refraction. So now, where actually you should be shoot at? So you can get the fish. Sebenarnya you nak tembak di mana? The shooter should be shoot a few centimeter below the image of the fish. So this is what the shooter need to do. He should shoot a few centimeter below the image of the fish. Then only he will hit the actual fish. Baru kena tembak bawah sikit, below the image seen in your eyes. Okay, then only you will hit the bull's eye. Right? Okay, and then D involve calculation. They give you the speed of light in air, 3 times 10 to the power of 8 meter per second. And then speed of light in water, 2.25 times 10 to the power of 8 meter per second. Okay, so you have to find refractive index of the water. Okay, and then find the real depth of the fish when the apparent depth is 1.8 meter. So in both solutions, student, you can use the equation. Just now I said there are three equations involving refractive index. So the first question, find the refractive index of water. So from this information, they give you speed of light in air and speed of light in water. How to find refractive index? So this one we apply the first formula. N equal to C over V. C is speed of light in air and V speed of light in medium. Okay. And the second question, you find the real depth by using the third equation. N equal to real depth divide apparent depth. Okay, so what will be the answer for number 1? So N equals C over V. C, 3 times 10, 8. V, 2.25 times 10, 8. So it will give you 1.33. Okay, 1.33. 1.33333 you'll get. Okay, then second, use this formula. N equal to H real depth divide apparent depth. So N is 1.33. Real depth, okay, uh, the real depth, find the real depth, apparent depth. So is this correct? Bawah real depth ke atas real depth? 1.33 H is the real depth, apparent depth. Betul ke soalan ini? 1.33 times 1.8. So 2.294. Okay, we check back the equation for real depth and apparent depth. Any mistake there? Can you check? The calculation correct for real depth and apparent depth? Okay, the real depth, find the real depth of the fish in water when the apparent depth is 1.8. So actually apparent depth 1.8. So ni terbalik apparent depth is 1.8. So I do correction first. Ni salah ni. Okay, so 1.33 equal to H. We are looking for capital H. H divide 1.8. Ni terbalik. Okay, this is the correct one. 1.33 equal to, okay, this one terbalikkan lah. Okay, this one terbalik. Okay, so 1.33 equal to H divide 1.8. Okay, so H ini capital H. This is capital H. So capital H is 1.33 multiply 1.8. So the answer is correct. Only the working here is wrong. So we please do correction there. So H is 1.33 times 1.8. So the actual depth should be deeper than the apparent depth. So 2.394 meter. Okay. So this is the correction on the working. 1.33 equal to H divide 1.8. Okay. So the real depth is 2.394 meter. Okay, students. Okay, next. Okay, so this is the final learning standard 6.1.6 to experiment to determine refractive index of a medium using real depth and apparent depth. Okay, just now we find refractive index from the experiment using glass block. Okay, now from the experiment involving real depth and apparent depth. Okay, so this is our diagram of apparatus and material. We need a beaker and then 2 pins. Pin O is acting as the actual object and pin I is to represent the image. And then we need a ruler and retort stand as well. So this beaker is filled up with water. So our manipulated is real depth. The real depth changes when we change the amount of water in the beaker. We pour different amount of water, so it will changes the real depth. Apparent depth is the responding variable. Okay, and then refractive index of water is the constant variable. We are using same type of liquid throughout the experiment. So this is the procedure. You can read A steel pin, pin O is placed at the base of the tall beaker, so it is acting as our object. Okay. Another pin, which is pin I, is mounted on the movable clamp on the rectangle. So we hang the second pin here. Okay. We hang where the height can be adjusted. And the beaker is filled with water to the depth of 20 centimeters. So from bottom to here, we measure 20 centimeters. Okay, remember depth is measured from the bottom, not from the surface. Okay, we measure depth from the bottom, so 20 centimeter up here. So pin O is observed from the above, so we observe from top. Okay, and pin I is adjusted until its position is at the same level as the image. So when we observe, you will see the image of pin O. So we adjust pin I to a height where you see the image of pin O at. Okay, and we measure its depth and record it with H. And then we add more water to increase the depth until 30 cm, 40 cm, 50 cm, and 60 cm. So whenever you feel the water mean you increase the depth, so what happened? The image will move closer to the surface. The image will move closer, higher and higher towards the surface. And later we plot a graph of H against H. Okay, so this is the, let's say this is the example of result gain. Okay, from the real depth 20 until 60. So the apparent depth also increases from 15 to 45. And we plot a graph of H against H. So it is a straight line graph from the origin. So we understand real depth directly proportional to apparent depth. Alright? Okay, students. So what is the analysis we can make from this result? Okay, number one, from the table, you can see apparent depth is lower compared to real depth. This is logic. Apparent depth must be always less than real depth, right? Mean the position of image always lower than position of the object. So second, we can look from the table. When H increases, when the real depth increases, apparent depth also increases. From the table, it shows increases in both column. And then third, the graph of H against H is a straight line graph passing through the origin. So we understand H directly proportional to mana-mana satu depan pun no problem. H directly proportional to H, capital or small h directly proportional to the other, right? Then when we find the gradient, okay, the gradient of the graph will be indicates the refractive index of the water. So here is 1.55 from the gradient. Here is 40 and here is 30. So we divide 1.55, right? So what is the conclusion? The ratio of real depth to apparent depth indicates the refractive index of the water. Okay, which is from this experiment is 1.55. Okay, the refractive index. So this is the formula relates. Refractive index, H real depth divide H apparent depth. As I mentioned in some book, they represent H with D. Capital D divide small d. So it's the same thing, no problem. You can use both. Okay. So last but not least, to solve a few problems related with refraction of light. Okay. Okay, all this question is took from SPM past year question, right? So diagram 5.1, 5.2 shows two position of the image. Okay, when two identical coins are placed under two different glass blocks. So this is the keyword. Placed under two different glass blocks, which means they have different refractive index. Okay, so this is the first glass block and this is the second glass block. So you can see this is the apparent depth for the first glass block and this is the apparent depth of the second glass block, right? Okay, this is the real depth of the coin in the first glass block and this is the real depth of the point in the second glass block. Okay, student. First, tick the correct answer in the box provided. So, refractive index of the glass can be determined by which formula? Real depth divide apparent depth or apparent depth divide real depth? So, answer is the first. Okay, real depth divide apparent depth. Okay. Okay, second. Okay, you have to observe these two diagrams and then compare the real depth of the coin. Okay, how to compare the real depth? Where to look the real depth? So look here. This is the real depth. Okay, this is the real depth for 5.1 and this is the real depth for 5.2. So diagram 5.1 greater than 5.2. Real depth in diagram 5.1 greater than that in 5.2. Okay. Second, compare the apparent depth of the coin seen by the observer. So this is the apparent depth in 5.1 and this is the apparent depth in 5.2. So you compare the height. Okay. So what's the answer? So you can see apparent depth in 5.1 greater than in diagram 5.2. Okay. For structure, you can straight away write the diagram. But for essay, remember you must write the parameter, must write the real depth, must write the apparent depth when you do comparison. That is the difference for answering comparison for structure and essay. Okay, I hope you remember it now because during the exam last time, most of you do mistake here in question number 11. You just write diagram 11.1 greater than 11.AB, which is wrong because you didn't include the parameter as well. Okay, then third, relate real depth to apparent depth. So how we relate real depth to apparent depth? So from the two relationship we conduct earlier, so we can say real depth directly proportional to apparent depth, or you can say real depth increases, apparent depth increases. Okay, I repeat, you can write real depth increases, apparent depth increases. All right. Okay, then for number 4, name the light phenomenon involved. So what is the light phenomenon involved here, students? So we understand light travel in two different mediums. So it must do with refraction of light. Okay, refraction of light. Okay, all right. Okay, so comparison relationship is a kind of question you shouldn't waste. Senang nak dapat markah di sini. So now I hope everyone know how is the format of comparing. Because Sadan last time a few of you also answer wrongly in question 5 and question 6 in paper 2 section and you don't know how to compare. So compare, either they are the same or which one higher, which one lower than the other one. Okay, that is comparing. Right. Okay, next. See, diagram 5.3 shows an incomplete ray diagram. So you have to complete them. How? Complete the ray diagram to show how the image is formed. So this is the actual coin. We understand the image of the coin will be appear above. Okay, appear above the real coin. So how to draw? This is the light ray coming from the first coin. So you have to complete this light first. So from glass block, then comes out to the air. What happened to the light? Refract away or refract towards normal. From glass block to air. From denser, optical denser to less optical dense. So it will refract, yes, very good, away from normal. So you show the light refract away from normal. Okay, here show refract away, where the angle of refraction is greater. So this is our angle of refraction. Okay, it should be greater than angle of incidence here. Okay, then how to draw the image? From the refracted ray, you draw a straight line. Okay, dotted straight line. Okay, until this point. So here is where we draw the image of the coin. The blue color is the image of the coin. So very simple. Kalau dia suruh buat dua garisan macam mana? Samalah. Kalau dua garisan macam ni, you do light as well. Ini dia lukis single, only single light. If they draw two light, then we draw two light also here. Okay, but if no light given earlier, so we have to draw two light ray. Normally we draw two light ray. Samalah. Ini the first light coming from here. Okay, then this one also refract away from normal. Okay, then we draw the bracket. So you just draw the image there where it should be above the real or the actual point. Okay, so this is the tips of drawing the diagram. First, 3 marks. How to determine 3 marks? First, you draw a light ray refracted away from the normal. So when you show this, you get the first mark. Okay, the first mark. And then continue dash line. So this is the dash line. Continue the dash line from the refracted ray. So this is your second mark. Okay, and then the third mark, when you draw the image of the coin exactly above the actual coin. So from this end, we draw the image of the coin, which is exactly. Then you can label image of coin. Okay, so this is the third mark. Okay, so you get the first mark, you get the second mark, you get the third mark. So complete all 3 marks for drawing. Okay. Okay, so I guess that's all with the example, student, for refraction of light. Okay, so we have 7 learning standard. Okay, from 6.1.1 until 6.1.7. Okay, anything, use greater force, hit a deeper position. What force is it? Chiha. Okay, any questions, students? Anything you would like to ask? Do you have your workbook with you? Do you have your workbook? I think I stop presenting now. Okay. So do you have your workbook with you? You can turn to page 124. We drew some exercises before we end our session, Can? Okay. Ada buku tak? Okay, your workbook. This one. Okay, so you can turn to page 124. Okay, page 124. We try to do a few questions today. Okay, 1 to 4, question 1, question 2, question 3, question 4, and question 5 as our conclusion. Boleh ya? Okay, first question. What is the meaning of refraction of light? Okay, student, what is the meaning of refraction of light? So what is refraction of light? You can refer to the PowerPoint slide or the module. So it is a phenomenon where the direction of light changes when travel through two medium of different optical densities. Okay, it is a phenomenon where direction of light changes when travel through two medium of different optical densities. Oh, cut it short. Cut it short where you can write direction of light changes. Okay, when it travels through two medium of different optical densities. Okay, that is the first one. Okay, dapat ke? Did you get the answer? Okay, phenomenon where, cikgu type lah jawapan dia sini. Phenomenon where the direction of light changes. Okay, when it travels through two mediums of different optical densities due to changes in speed. Okay. The arrangement you can follow the answer in your module. Okay, phenomenon where direction of light changes when travel through two medium of different optical densities due to changes in speed of light. Okay. Second, you have to draw the direction of refracted ray and mark the angle of incidence and angle of refraction as well. Okay, number 2, page 124. You have diagram A. The light ray is travel from A, the first medium, entering glass block, the second medium. Okay. In diagram B, the light ray is travel from glass, the first medium, entering air, the second medium. Okay. So diagram A, you should draw the light ray supposed to be refracted away or towards, students. Diagram A, from A to glass, away or towards normal. Away or towards. Royhan, away or towards. Jia Cheng, away or towards. Diagram A, from A to glass. Xin Yan, what do you say? Towards, yes, should be towards normal. Yes, towards. Bayan, towards normal. So, you draw a line towards normal. So, label I and R as well. And don't forget the arrow. Right? Okay, what about B? From glass. Okay. Entering air. So, away or towards. Panjin should be away. Very good. So, you draw refracted away from normal and label I and R as well. Where to label I? In between incident ray and normal. Where to label R? In between refracted ray and normal. Don't label at the wrong side. Alright? Okay, what about 3? Number 3, students. State the change of velocity of light after refraction. So you have to state the change in velocity. So change in velocity, either the velocity increases or decreases. So what happened in A? Increases or decreases? From A to glass. Increases or decreases, students? What happened to the velocity in A? Decreases or increases? Why question mark there, Jara? No confidence? Yeah, you should be more confident. Yes, answer is decrease. Remember, from A to glass, the speed or the velocity decreases or reduce due to the glass particle. So it slow down the movement. So yes, answer for A, decreases. What about B? So B, from glass to air. So refracted away, which means the speed or velocity increases. Yes, so it is decreases for A and then increases for diagram B. Okay, number 4. What is refractive index, student? What is refractive index? Okay, what is refractive index? Actually, here you can give 3 different answers. Okay, the general one, it is the ratio of speed of light in vacuum to the speed of light in medium. Okay, that is refractive index. The ratio of speed of light in vacuum or air to speed of light in medium. Medium here can be any medium. Okay, ratio of speed of light in vacuum or air to speed of light in medium. Can you guess another 2 answer you can write here? It can also be the ratio of sin I to sin R. Ini pun boleh terima. Ratio of sin I to sin R. Or you can say the ratio of real depth to the apparent depth. Okay, the ratio of the real depth to the apparent depth. All these define refractive index. Okay, where the first answer n equal c over v. The second answer n equal sine I to sine r. And then the third refers to n equal capital H divide small h, or capital D divide small d. Okay, and then state the equation for Snell's law. Okay, they give you the parameter n1, n2, theta 1, theta 2. So how to relate this? So you can write n1 sine theta 1 equal n2 sine theta 2. Okay, so what is n1, students? Number 5. Okay, they give you n1, n2, theta 1, theta 2 there. So how to relate them? You write in the box n1 sine theta 1 equal n2 sine theta 2. So n1 sine theta 1 equal n2 sine theta 2. Okay, this is the equation. So what is n1? n1 is the refractive index in the first medium. Okay, and 2 refractive index in the second medium or medium 2. What is theta 1? Theta 1 is the angle of incidence in the first medium, and theta 2 angle of refraction in the second medium. Okay, and refer to textbook or refer to your module. Boleh nampak tak jawapannya? I think it's very very small. Never mind. Okay, so you just write. Okay, N1, I repeat, refractive index in medium 1, and 2 refractive index in medium 2, theta 1 angle of incidence in medium 1, and theta 2 is angle of refraction in medium 2. And remember, student, medium 1 always Medium 1 must always air or vacuum. Okay, medium 1 must always the air or vacuum. Okay, if the light travel in the opposite way, then you can apply the principle of reversibility of light. Okay, to apply Snell's law formula. Okay, remember, medium 1 always the air or vacuum. Okay, are you done with number 1, 2, 3, and 5? Who else we have here with us? Are you done, Yiwen? Jiaken? Okyen? Roshan? Charmaine? Okay, okay. Do you have any further questions, students? So how do you find 6.1? Can you deal with it? Student 6.1. Nanti balik semula, tak susah tajuk ni tak susah, senang saja. So you can try do or complete experiment 6.1 and experiment 6.2, boleh cuba, and then you can try to solve question number 7 on page 130. Okay, page 130. Okay, can you go there now, page 130? 130. 130. Question number 7. Solving problem involving refraction of light. Okay, we try first. Question involving calculation. Okay, are you all there? 7A. Okay, we have a light ray travel from glass to air. Still travel from glass to air. Okay, refractive index of the glass 1.54, highlight, and then the speed of light in air 3 times 10 power of 8 meter per second, highlight. So you can highlight these 3 information. First, it travel from glass to air. Second, refractive index of glass given 1.54. And then third, information, speed of light in air 3 times 10 power of 8 meter per second. Okay, find the angle of refraction. So how to find angle of refraction? It is labeled as theta there. Okay, labeled as theta. So try to find what is theta. And then you can type your answer here in the in-call messages. So here now, the diagram, the light travel from glass to air. So what we need to do first, we can apply what principle we can apply here, student? Anyone? What principle we can apply here? You remember, if you want to use Snell's law formula, the light must travel from A to the glass. So here we can apply principle of reversibility of light. So you can reverse the arrow. So first, you can reverse the direction of arrow. So make the light ray travel from A to the glass. Okay, reverse the arrow. So now theta is angle of incidence. 30 degree now is our angle of refraction. Okay. Okay, then you can apply Snell's law. So which law we can apply here? The first one, the second, or the third? Which formula? The first, second, or the third? First is N C over V. Second, N is sine I divide sine R. Third, N H divide H. So which one? We can apply the second formula. N equal sine I divide sine R. Okay. Okay, fine. So we apply this formula. N equals sine I divide sine R. Okay. So what is N? N is given 1.54. So 1.54 equal to sine I, we don't know, divide by sine 33 degree. Okay. So find what is I. So from here, sine I is 1.54 multiply sine 33. Okay. So Chihang got 57. 57 what, Chihang? What is the unit? 57? Yeah, very good. So did you get 57 degrees? So answer is 57 degrees. So I equal 57 degree. Okay, 57 degree. Okay, you put the degree symbol up there. 57 degree. Okay, very good. I hope the rest also got 57 degree. Okay, now find the speed of light in glass. Speed of light in glass. So here, which Snell's law formula we can apply? The first one, the second, or the third one? Definitely, yes, the first one. Very good. So what is the first one? N equal C divide V. Okay, N equal C over V. Okay. So what is N? N is 1.54. What is C? C is speed of light in vacuum. 3 times 10 power of 8. Okay. Power of 8. Then divide V. So you can find V. Okay. Find V. So if you're done, you can share your answer for V, speed of light in glass. Okay, so when you arrange the formula, V equal 3 times 10 power of 8 divide 1.54. Don't do it oppositely. Kini hati-hati Jangan silap divide. It happened during the exam last time. So what is the answer? Chihang, what is the unit? Can you put them in standard notation? Put them in standard notation. So answer will be 1.9481 times 10 power of 10 power of 8. Correct? Power of 8. And the unit is meter per second. Okay, don't forget the unit as well. Okay, student, can we put our answer as shown by Chihang? Actually, no problem. You can leave your answer that way. 194805194.8 meter per second. Boleh. Jangan letak one decimal place saja, Jaren, as I mentioned. Okay, it's not safe for KSSM format. Okay, you put 3 or 4 decimal places. So here I put 4 decimal places as a safety measurement. A 1.99481 meter per second. Okay, ingat jangan letak one decimal place. Itu sangat-sangat salah lah. Two, maybe they will consider, but it is safe if you use 3 or 4 decimal places. So here I choose a 4 decimal places together with the unit. Okay, okay then. Okay, I guess for the last question, you can try B. We have an incomplete light ray entering a glass prism which have refractive index of 1.5. So you can highlight the refractive index of the glass prism is given 1.50. Okay. Then the light is entering, okay, at 90 degree. So first, it enter no refraction because it travel exactly at the normal. But when it reach the second line, the slanted light, so you can see angle of incidence there is 30 degree. Okay, so 30 degree and the dotted line is the normal. So where is the refracted ray? Away or towards normal, student? From the boundary of angle of incidence 30 degree, so away. Yes, very good. From glass prism to air, so from higher optical density to less optical density, it will refract away from normal. So the refracted ray going up or going down? Away. When you draw refracted away, going up or going down? When you drew the drawing, going up or going down? It should be go down, away from the normal. So you should draw the refracted ray goes down, okay, away from the normal line. Then you can mark the angle of refraction there with R. Okay, find the angle of refraction, student. Find the angle of refraction. Okay, what is the angle of refraction here? So what about this question? Must we do similar as 7A? Must we reverse the direction to find the angle of refraction? So now, yes, you have to reverse. Now your R become I and your R become 30 degree. Okay. Your angle of refraction in A now become I, angle of incidence, and your angle of incidence 30 degree now should be R, angle of refraction. So you can find what is the angle of refraction in the air. Okay, cuba kira. So here again we use the first, here we use the second Snell's law formula. N equal sine I in air divide sine R in prism. Okay, so this is the guide for you so you won't lost. So 1.50 equal to sine I, we don't know, and divide by sine 30. Okay. So what will be our I? Okay, so answer Chihang got 48.59 degree. Okay, very good. Correct. 48.59 degree. So that's the answer. What about the rest? What do you get? Do you agree with Chihang? So answer 48 points. So I equal 48.59 degree. Okay. Okay, so I guess you got the point how to determine angle of incidence, angle of refraction, speed of light, either in air or in a medium by applying Snell's law formula. Okay, so remember there are three formula you can apply regarding to the situation given. Okay, either n equal to c over v or n equal to sine I divide sine r, or it can be n equal to real depth divide apparent depth. Okay, so I guess with this example we've done with 6.1. Any further question you can ask later when you're back to school, but I'm afraid for next week we will have some changes where the UASA will be continue exam for Form 3. So they will be on school. And then you will have another cuti bergilir. So maybe next week also you will stay at home. All Form 4 students. Okay. So I think we will continue with the online classes. Tomorrow, remember we have another series for 6.2, same time 9 to 11 a.m. So I guess more people will join us tomorrow. Thank you very much for your efforts, students. Thank you very much for your time. I really appreciate them. Okay, so anything you can PM me in Telegram for any further question on 6.1 refraction of light. Okay, so I guess that's all for today. Thank you and see you again tomorrow. Bye bye. So you can continue with your games now. Ruyang, boleh sambung main game. Okay, thank you. Bye bye.
Thank you, teacher.
Welcome.
Out of curiosity, do I have to send the attendance to you?